Over the course of this series, we've looked at the importance of open input, multiple models, estimation, connections, mental computation, and creative thought. But there's one feature that sits underneath all of these. It's what students say, hear, and think. Because number sense doesn't grow in silence. It grows in explanation, in questioning, in challenge, and students listening to others reason about their thinking. In this final episode of the series, we're going to explore the role of language, discourse, and personal thinking in developing and building number sense. If you've watched all the previous episodes in this series, you probably already know just how important student language is. We simply can't learn without our language, but some tasks or activities really bring learning to the surface more than others. Let me explain using a real simple task that I like to use with students. Write a short story problem that has 12 as an answer. That's it. No operation, no numbers other than 12, no hints, just the answer. Now watch what happens. One student writes, there were 6 birds and 6 more birds join them. How many birds in all? Another writes, I have $20. My sister has $8. How much more money do I have? The third one writes, there are 3 bags with 4 chocolates in each. How many altogether? Same answers, completely different stories. And this is where language becomes powerful, because when students write the story, they have to decide what is happening. Is something being joined, taken away, grouped, or compared? They have to identify a beginning, a change, an end. So instead of asking, what's the equation? Try asking, tell me a story in your own words. Is there action in your story? If so, where? How could you use materials to explain your story? When students explain their stories, you suddenly get a window into their understanding. Do students think of multiplication as being equal groups? Do they see subtraction as being takeaway or maybe difference? Or do they see addition as being putting together or maybe something less active? 2 different students could both write 6 plus 6 for the answer, that's 12. But maybe only one of them truly understands what 6 plus 6 represents. Number sense grows in explanation, and not as much when we give them stories, but when they create their own and they start listening to others who explain their stories. Now, this particular problem or activity requires them to write their story, but you could simply ask them to verbalize their own stories. We've just seen how language reveals understanding, but language on its own is often not enough. A student can write or share a story and they can explain what is happening, but number sense strengthens when they share their language. So one student's explanation becomes another student's opportunity to question, extend, or even challenge. Let me share a simple activity that shows the type of discussion I'm talking about. Consider each statement. What do you notice? What do you think? When you multiply a number by 10, the answer is greater than the original number. When you multiply 2 numbers, the product is greater than both numbers. When you subtract 2 numbers, the answer is less than the first number. If 2 numbers add to 12, one of the numbers must be greater than 6. When you divide a number by a number greater than 1, the answer is always smaller. This task doesn't require students to calculate anything. It asks them to pause, to read carefully, to think about what the statement is really saying. You might want to prompt student thinking with questions like these. What do you notice? What makes you think that? Can you give an example that supports your idea? Can you think of a different example? Would that still work if the numbers changed? Now the classroom feels different. A student might begin by saying, multiplication makes numbers bigger. Another student might offer, what about multiplying by 1/2? Someone else might adjust the original claim so it becomes more precise. As the ideas move around the room, students start listening more carefully. They weigh the examples, they test possibilities, they pay attention to the size of the numbers and what the operation is actually doing. The language tightens because the thinking tightens. You begin to hear students talk about scale, about magnitude, and about whether the result makes sense before they do any computation. Now that type of questioning encourages students to reflect before they speak, and that reflection is where personal thinking begins to take shape. Now let's take a look at that. I want to show you a task that I've used for many years. It works across many grade levels because students bring their own experiences to the activity. I had $100. I spent more than $50. How many items did I buy? What was the cost of each item? And then what was the total cost? Typically the first response I get sounds something like this. I bought one item, it cost $75, so the total was $75. But then one student usually pushes it a little further. No, I bought two items and they cost $40 each, so I spent $80. Now the thinking starts to expand. At this point, the teacher has a choice. We can accept a couple of answers and move on, or we can stretch their thinking. Try prompts like this. Suppose you bought 4 items. What could the other numbers be? Suppose you bought 5 items, or 10 items. Suppose you bought more than 10 items, or maybe more than 100 items. Now students are exploring number relationships. Suppose each item costs between $10 and $20. What might work? Suppose each item costs less than $1. What would that mean for the number of items? Now magnitude enters the conversation. Suppose the total was between $80 and $85. What could the other numbers be? Suppose the total was exactly $65. What could the other numbers be? Students begin testing ideas mentally. They estimate before calculating. They consider reasonableness. They adjust and refine. Some will revise their first answer. Some will realise their earlier thinking was limited. Some will discover patterns. And that is personal thinking. Each student brings their own experience with money, multiplication, and number relationships. Each one forms an initial idea. Then through questioning and discussion, that idea is stretched. Although the task itself is quite simple, the thinking that it can produce is sophisticated. And this is where language and discourse and personal thinking comes together. And in that process, their number sense grows. So as we land the plane on this series, this is what I want you to do. 1. If we create classrooms where language is intentional, discourse is valued, and personal thinking is expected, then number sense will follow. 2. Try using the short tasks in the link below with your students so you can practice your questioning skills. The aim is to get your students to think, to explain, to justify, and to rethink if necessary. And finally, if you found value in this episode, please give me a thumbs up and share it and subscribe today so you never miss another learning opportunity with me. See you next time.